Some people take Ozempic or Wegovy for a full year and barely lose anything. Not because they're cheating and not because they're not trying. Scientists now believe it's because of how their brain is wired. In the landmark Step 1 trial published in the New England Journal of Medicine, the average weight loss on semaglutide was about 15%. But some people lost nothing. In real-world clinics, roughly half of patients lose less than 5% after a full year. Here's why. These drugs don't just slow your stomach down. They work on brain circuits. The dopamine reward system, the hunger centers, the craving circuits. GLP-1 receptors sit on the hypothalamus, the nucleus accumbens, the ventral tegmental area. Here's the exact pathway scientists mapped. When you take GLP-1 drug, it activates the brainstem, or called the NTS, excites the GABA neurons in the VTA, suppresses dopamine release, and then you get less food craving. For non-responders, this chain breaks somewhere. So, your brain never gets the memo. Also, if your brain has lower GLP-1 receptors in those regions, which also can happen, the drug's signal barely registers. There's another problem. Semaglutide is a large peptide. It can't freely cross the blood-brain barrier. It relies on a tiny leaky zone in the brain called circumventricular organs. And this also requires an intact vagus nerve. Damage, either of those, from diabetes or inflammation or neuropathy, and the signal never arrives. Scientists found 3 brain regions that control whether a GLP-1 drug works. They are the dorsomedial hypothalamus, the hindbrain, and the lateral septum. Different people have different GLP-1 receptor density in each area. So that means less density of GLP-1 receptors, less response. More density means more response. Full stop. In April 2026, a study published in Nature Journal involving nearly 28,000 people on GLP-1 drugs found specific gene variants in the GLP-1 receptor gene that predict how much weight you'll lose. Your DNA may have been telling the story all along. And it's not just weight loss trials. Scientists tried using these drugs for Alzheimer's and Parkinson's diseases, conditions where the brain desperately needs help. A 2025 meta-analysis of 15 clinical trials and over 1,300 patients found no meaningful cognitive benefit. But animal models work perfectly. Human brains are far more complex. But why? Because human biology is a patchwork quilt. No 2 people are the same. Gender, genetics, diet, exercise, underlying causes, environment we live and work, socioeconomic and family cultural values make each one of us unique. We are not one size fits all. Diseases do not develop like one size fits all in individuals. So, therefore, there will be no universal treatment to all. There will always be outliers that do not follow the normal pathway expected. And that is okay. This is why precision and individualized medicine is becoming more and more accepted each day. And this applies to GLP-1 treatment as well. So, What's coming next? Scientists are already working on it. Next generation drugs are being redesigned specifically to cross the blood-brain barrier. Gene testing may one day tell your doctor which drug to prescribe before you even start. Non-response isn't failure. It's a solvable biology problem. And science is catching up fast. Follow for more threads like this. Join me on Substack for deeper dives and for clinical updates daily on Twitter and YouTube.